I welcome everybody to another LINQ.NET user group presentation together with the cool guys from Wintellect. It's the 8th of August and this is our third event this month. We had 2 events last week. Before I go in and I hand over to Mitch Harpur, who's going to be doing programming inheritance using JavaScript tonight, I'm just going to go through a bit of the usual housekeeping. First and foremost, thanks to our sponsors, Orgsweb, Telerik, ProSite, Wintellect Now, and SyncFusion for their continued support. Without their support, what we're doing and what we're delivering to you guys just would not be available. If you need to get hold of us, you can send us an email at info@lidnug.org. You can also catch us on the social with both twitter.com/lidnug and on facebook.com/lidnug. All of our sessions are recorded and they are uploaded to our YouTube channel, which is youtube.com/lidnug. Also, find our website, which is hopefully soon going to be redesigned at bit.ly/lidnug. September 19th, we're going to have another event coming up, LIDNUG and Wintellect again, and this is just Lane presenting Cloudy with a Chance of Data. There is also one on the 10th of September, but I'm just getting the last final details for that, and then it will be published. You can find all of our events, published events and upcoming events at lidnugevents.eventbrite.com. So a little bit about Mitch. Mitch, this is, I believe, his second LIDNUG event. I didn't know this myself, but he's a former electrical engineer. And you can also catch him on Twitter. Metanusia is his Twitter handle. He's a senior consultant from Wintellect. And I want to hand over to you, Mitch. Thank you and welcome on board.
Thank you very much. Welcome, everybody. It's absolutely a great joy to be here. Let me just select my slides here. Great. Can everyone see the pure rage? I hope so.
Yeah.
Good. Excellent. Right. So thank you for that wonderful introduction. Yes, I am a former electrical engineer and I went mad. So I went over to software, right? My name is Mitch Harpur with Wintellect, and today we're going to be talking about JavaScript inheritance. Right, because nothing makes you crazy or angry as trying to make JavaScript do what you want to do. So the reason I'm looking forward to today is it gives me an opportunity to sort of have a conversation with you guys about how to think about JavaScript inheritance. For many people, you know, the default is just to use some library. And that's great. You know, I think for a lot of bread and butter projects, that's good. But it's helpful to understand the fundamentals. In engineering, you always think of, you know, deriving things from first principles because it's the way you think that counts. And then once you've got that figured out, yeah, sure, use other libraries, use things, use what's good. But I think it's a good thing to have a handle on the actual gist of it. So we're going to talk about that, and I hopefully will give you some tools to alleviate your pure rage and frustration with JavaScript, and realize that it's actually quite a powerful mechanism for doing JavaScript. Inheritance in JavaScript, rather an interesting concept. So Wintellect, as we've had such a great introduction, but Jeffrey Richter, Jeff Precise, and John Robbins founded the company pretty much over a decade ago, and we do consulting and training, and we love to do that. We're very passionate about that, and if you need something, you need training, you need online training, on-site training, customized training, talk to us. We can almost certainly help you, and we would love to be able to help you get where you need to be. We have something new, though. We have online on-demand training, and if you look at the little promo code in the top right-hand corner, LinkedIn 13, you can get a free trial to try out and see, okay, are we as good as we say we are? I think you will be convinced that we are. We have something to offer. I don't want to be arrogant and say we're the best. I think we're the best, but that's because we're passionate about what we do. So go in and try it out. There's a lot of good sessions on there on all sorts of things. Now I'm going to shamelessly promote myself and say, yes, I have done some online training there on JavaScript, so go and look there. But there's lots of great content about .NET, about JavaScript, and several platforms that are really good. So that is Wintellect now. Go and have a look at that. Now let's see. Diving in, JavaScript. How do you squeeze an elephant through a small hole, right? A small door. Well, some things in JavaScript, let me just set the platform here. Some things just won't work, okay? Let me be honest and truthful. That doesn't mean that you can't force it. It's just that when you force it, things break or things just get complicated and messy. So while we're going to be talking about JavaScript inheritance, the goal is always to keep things simple. It's all very well if you've written your own framework and you're using it. But if others have to consume what you did and you did some fancy thing, it's good up to a point, but it's going to create a problem for you. And it's going to make you angry. It's going to frustrate the living daylights out of you. So we strive to keep things simple to make sure that you can have a good experience, and also just to give you a rationale to realize that JavaScript environment is just different. Okay, if you're a C# programmer or .NET programmer, that's great. It's awesome. It provides an environment. It gives you a lot of stuff, right? JavaScript has its own rules and its own way of doing things. To the Romans, be a Roman. I think that's going to help you with JavaScript. And when you accept that the way things are done in JavaScript are a little bit different, you're going to find peace for your soul. So, just do your best to accept it and breathe in and all will be well. So I'm trying to brace you for what comes, right? Now, I said things are different. Well, in JavaScript, yes, things are indeed different. And I think when I delve into some of the prototype chain stuff today, you will like, oh, help me, I'm drowning. This is nuts. It doesn't make sense. Yes, at first it does seem that way. It feels wrong. But breathe in, absorb it, try to accept what is there. And before long, you will find yourself quite comfortable in both server-side typed environments and client-side JavaScript environments when you think about things in the right way. And who knows, before long, you might have web feet and be just as comfortable on the language of the web, which is JavaScript, right? Okay, so that's all very well. I've given kind of a long intro, but how do you get there? How do we think about JavaScript? Well, I think you have to look at how things are built. When you look at JavaScript at a sort of core level, if you're going to be talking about inheritance in JavaScript, which is as I say again, the topic of this talk, what is there? What are the essential building blocks? If you're in C#, you've got a compiler, you've got a strongly typed environment, you've got a very clear way of defining inheritance. In JavaScript, you've got a different set of tools. So we're going to look at objects. What are objects in JavaScript? What do they really do? And then we're going to talk about primitives. And that kind of comes up second there. The reason why primitives are important is because if you're a .NET programmer, you're used to everything being an object, right? And the common wisdom in JavaScript is everything is an object. Well, that's just not true. And you're like, wait a minute. Yep, it's not true. There are things called primitives in JavaScript. And the primitives are basically the irreducible types in JavaScript. And there are three main ones, two sort of state value ones with a total of 5 that you need to be aware of. And I'll explain that in a moment, but it's an important thing to remember, because if you're building abstractions and you want to define inheritance, it's good to understand what are the building blocks, right, like I said. And we're going to talk about prototypes. And I'm sure we've all somehow run into the prototype object, and that was thunder in the background, if you heard it. Yes, thunder kind of goes in line with the idea of a prototype. So the prototype is just a way of building up functionality in an object, and we'll delve into that nicely and deeply today, I hope. I'm actually going to write some code. I'm going to be using codepen.io. It's an online JavaScript environment. And the reason I'm doing this is because I actually want to show you, when I write code, what does the interpreter actually see? And so I'm going to use Chrome with the debugging tools enabled so that we can see, gee, when I create an object literal, what is actually there under the covers, and how can I use that to define inheritance? And I think that will go a long way to helping you understand. So those are really the three areas we're going to cover today, and we'll sort of dig into depth. Now, like all things, right, be careful what you think you know. It will trip you up. There's stuff below the surface in JavaScript, which is, if you apply the rationale with C# and typed environments, you're going to get yourself into some trouble. And it's just because it's familiar syntax, it's not the same thing. All right? Underneath there's weird stuff. It's not really weird, but it feels weird at first. So be aware of that. Okay, so onto primitives. Really, in JavaScript, there are three main primitives that you need to be aware of. All right? And as I said, these are the irreducible building blocks of JavaScript. And I'm not talking about object. I'm talking about the Boolean, which is a true and a false. We're talking about number, and we're talking about string. Now, these are core primitives which you copy by value. They don't copy by reference. And no, these are not objects. Now, you may say, well, hang on a second. I thought those were objects, like we have a Boolean object in JavaScript. Well, there are wrappers which convert the primitives to objects. But that's why in JavaScript, because you have these primitives, all the operators are usually done in terms of primitives. And usually the operating system, in order for it to make sense out of things, it first converts it to primitives before it does the operators. Or at least it uses the operators to convert them to primitives, but then it does the actual action of the operator. Now, why am I talking about primitives? Well, because the conventional understanding is that these three types are objects. And some of the other objects which people think are core or primitives are things like the date object or the array or the regular expression. Well, those are not actually primitives in JavaScript. They are really just derived, for lack of a better word, from the core built-in object. And those are differentiated from each other purely by having a different prototype. And other than that, there is no difference. Now, the wrapper objects which wrap these three core primitives are also just objects which differentiate from the other objects by also just having their own custom prototype. And that's really all there is to it. The other two, which are technically called primitives, are null and undefined. And null is, you've got to think of these two primitives as, like in C#, null is really a value, right? Well, in JavaScript, it's also a value. It's kind of like state, but it's also regarded as a primitive, all right? So it's understood in a core sense. And then undefined, which means, hey, I can't find something. So if I have a variable that's undefined, the interpreter says, I don't know where that is. I don't know what you're talking about. But there's another use for undefined, and that's when you initialize, when something is uninitialized, it usually has a value of undefined. Not usually, always does. So those are the primitives. Why is that important with objects? Because if you understand this, you'll realize that everything in JavaScript that is an object follows the same rules. And being able to differentiate when you're dealing with a wrapper to a primitive type versus the actual primitive type, it goes a long way into clarifying things. So those are the primitives. Now, let me kind of take it a step further. Okay, so objects. We've talked about a few objects, right? Date. We've talked about the wrapper objects, the number, the string, and the Boolean. We've talked about regex, just as an object. But what is an object in JavaScript? Well, an object is nothing but a collection of key value pairs. If you are a .NET developer and you're used to C# or VB, think of an object as a dictionary of string object, where the object itself can be pretty much any value. And that is really all an object is in JavaScript. It's just this lookup table where if you try and access a property, well, somewhere in that object there's a key with that property name and it has a value. And everything that you build in JavaScript is going to be based on a collection of key value pairs. That is why when you do a for each on a JavaScript object, you can enumerate, almost a kind of reflect over an object. But from an abstraction perspective, what is an object? If you think of an object in sort of C#, it's this base unit of abstraction, right? Where we think about some arbitrary problem and we try and define it in terms of what it is. And we say it may have state and it may have behavior. In JavaScript, it's the same thing, right? It's a container for behavior and state. Now, you may be working towards a particular abstraction, or you may be just using it as a stateful object, like an array. An array in JavaScript is nothing but a regular object of key value pairs where the keys are integer-based lookup values. There's no sense of an array like in C#. It's very different. It's just a pure object like any other object. But then you may ask, so how do I get all those extra methods, all those extra functions that are shared between all arrays in JavaScript? Well, this is kind of delves into the topic of prototype. Now, a prototype, I found this quite confusing in the beginning because every object, literally every object in JavaScript has a prototype. Yes, even the primitive wrappers. A prototype is a place where you put the functionality that's reusable. So if you think of it in terms of, if you had a classic C# class, think of it as an internal static dictionary. And that might be a good way to think of it. But a prototype is in of itself just another object. So why put it there? Why not have an object with just methods and behaviors? Well, there's a thing called the prototype chain, and this is how you can kind of borrow behavior and state from other objects. So every object in JavaScript has this hidden property called prototype. And by the way, I'm not just going to talk about this stuff the whole time. I just want to set a foundation. When we go into some code now, we'll kind of, you'll see, I'll bring this all together with some sort of practical digging down into an object. But every object in JavaScript has this hidden property called prototype. It's underscore, underscore, prototype, underscore, underscore. And what it is it's just another object that helps you to define shared behaviors in between objects. Now, it's not normally accessible. All right, so like Chrome and Firefox, at least their JavaScript implementations allow you to access the property, but like IE, you can't access this underscore prototype property. It's kind of like a private member, for lack of a better word. But you can access it through ECMAScript. So there's a thing called object get prototype off, and that's just a method of the core object in JavaScript. And if you call that function on give it as an argument any object, it'll give you the internal hidden property, prototype property. And like I said, this prototype is just another object. It's not a function. It's just another object. Now here's the funny thing. That prototype, because it's an object, right, also has a hidden prototype property. And it works its way all the way up until object prototype, which is basically null. So the object hidden prototype property is just the value null. So all objects have these prototypes, and prototypes have other prototypes, and prototypes works the way up until it gets to object prototype. Just like in C#, right, where everything derives from object eventually. So kind of in the same way, every object has a prototype. All right, and I'll explain why that's very, very important. Arrays, functions, regular expressions, the wrappers for string, number, and boolean, those are all just objects with specific behaviors defined in their prototype object. So if you take a standard object, right? And you set the properties in you set the methods in the prototype of an array. You can convert that object to an array. Because what differentiates the type of the object in this sense is really the prototype. And we'll explain that really nicely when we get into code. Right, so here's the interesting thing. Because it's another object, remember I said in the beginning how all objects are just key value pairs. Well, when you access a property on any object, what it does is it looks up the prototype chain, and the first match it finds, it returns that value. So let's say you have an object called animal, and it has a property called classification. And let's say that animal object has a hidden property called a hidden prototype with another property called classification. When you read the classification property, it'll return it from the first one in that prototype chain. However, if your object doesn't have that property explicitly defined, it'll go to the prototype and look for it there. And if it doesn't find it there, it'll look in its prototype, and it works its way up. And the first one it finds, it'll return that value. And that's how you can inherit value. That's how you can store method and behaviors up the prototype chain. But here's the kicker, all right? When you write, it's not the first one, but the closest one is written to it. So it's always the bottom of that prototype. That's where it's written to, even if it exists high up. And this is where it's different from C#. If you think of a class hierarchy in .NET, right, it's something that's a compile time construct, essentially. And when the object is instantiated at runtime, you have one object. And the behavior, even if you've got virtual inheritance or new or overridden properties, there's one instance in memory. However, when you have a prototype chain in JavaScript, there are many instances that collectively form the collective behavior of that sort of most derived object. And that's very, very, very important distinction to make between inheritance in JavaScript and inheritance in C#. Right? So that is why when you write to a object or write a property to JavaScript, it's going to go to the most derived instance. But there may be other instances up that prototype chain that same property, and they won't be overridden. And if you're sharing prototypes and stuff like that, you get some funky behavior or unintuitive behavior. So just bear that in mind. Right, so this is what I'm explaining. Let's look at this diagram. So I have a child object, right, and inwardly it has this prototype property which points to another object, which I've just called the parent in this case, right? I'm not thinking inheritance necessarily. I'm just saying it's another object. And it also has a name Adam. And of course, like I said, because every object has a prototype, eventually it works its way and it has an object prototype which has a prototype value of null. Now, if I access or read the name Bob, then it's going to read it from the child object. If the name Bob didn't exist and I access the property name from the child object, it would go to the parent and read the name Adam. All right? And if it didn't exist there, it would go up to object prototype and so forth and so forth. But if I was writing a value, let's say name didn't exist on child, and I said child.name equals Bob, it wouldn't write it to Adam, even though it didn't exist in child. It would literally add it on the fly to child, because these are instances. Whereas in C#, these would all be merged into one physical instance. So I want you to bear that in mind, because that's a very, very, very important thing. So I'm going to just switch over to some code to try and illustrate and just show you these basic principles. So let me switch over for a moment here. And so I've got CodePen open here. And what I've done here, CodePen is just an online JavaScript editor, and it's just very nice to edit and type in so we can see things, because it kind of runs the JavaScript on the fly. And I'm running this in Chrome. And what I've got here, I've got the developer tools open. And I'm going ahead and clearing the console. So every time I make a change, I clear the console. and then I write out the object. So look what I'm going to do here. I'm going to just create a object literal. So let's say var object literal, and of course I just assign it as a JSON literal, right? We're familiar with this. Now I want to see what is in that object, because I've spoken about prototypes, I've spoken about how every object has a prototype, and that how do I connect the dots here? So let's look what happens here. So I'm going to output the object literal, and let's look at the values. Let's expand what's in here. So this object literal value has an inner prototype property, all right? And inside it has a whole lot of functions. In other words, these are methods of its prototype property. But I want to draw your attention. Let me just zoom this a bit here. I want to draw your attention to, we've got the prototype property, all right. I want to draw your attention to the constructor, all right, and this prototype. So the object itself has a prototype, and this is just like any other object, see there, and it's got a whole lot of internal methods, but it's got some functions that you can call, and you can see things that you may be familiar, the value of method, the toString method, to local string method is prototype of method. These are all just methods that are defined in the core object prototype. And so every object that you create, even though you do a literal, it's created from the core built-in object which has a prototype. And that's the prototype chain. Let me exit Java. Now let me do something else here. Let's say this was a function. Actually, now in JavaScript, all things except primitives are objects, right? Even functions are objects. Well, that means if it's an object, it has a prototype property. So let's look here. So I have a function, and guess what? The function itself has a prototype property. But the prototype has a couple of extra methods that are normally different from an object. But remember I said every prototype itself also has a prototype. Well, look, there's its prototype. If you go up to the prototype of the function of the prototype of the function object, you notice it's just the regular object prototype. And that's that prototype chain that you have. So the methods which differentiate, the things that differentiate the function object from, let's say, the array object, are just its prototype. Other than that, there's no difference between them. Now, of course, a function has a special characteristic in that it has a extra prototype property, which is public. One public, one private. Now that, okay, don't get confused here. This has not been clear to me, you know, it was not clear to me for a long time. But the pin dropped when I realized that this prototype, which we'll talk about when we go back to the slides now, is something that is used when the new operator is there. So that allows the function to behave as a constructor, which defines the prototype that will be used to create the object which is created from the function when it's used as a constructor. All right. So that's what that is. These two are different things. Every object has a prototype, and when you look in Chrome tools, it's the underscore proto. That's the prototype of the object, not this public prototype property. Okay, so just bear that in mind. And notice that this prototype is not a property of the function prototype. It's actually a property of the actual function object itself. All right, so in other words, it's the most derived type. whereas the prototype contains its all inner functions. Another thing that the function prototype has is call and bind, and this helps you to define context when you're using objects. You know, the this parameter allows you to call things with the correct this value. But another thing that is really important here is it has this thing called a constructor. And you can see that if I have a object, let's say let's go back to this, just the regular literal object, all right? There's the prototype. I'm zooming in now, right? It also has a constructor object, but the constructor is the function called object. So that's interesting. What if it was an array? Well, it turns out it also has a prototype which has a constructor, but there the constructor is the array function. Interesting. So this constructor, what it really is, it's just action. You can access it, because remember I said that you can access properties of a prototype by just accessing with arrays. If I say constructor, where is it? Constructor. Just read it here. Just bear with me a moment. Yeah, and just change it. So that's undefined. I'm doing something wrong. Give me a minute. I'll come back to this in a moment. I think I'm doing something wrong in this presentation. Let's just step back a moment. Okay, so you've got your console, you've got your prototype, and it has your constructor object, right, which is the function. That's right. It's the function which is, sorry, excuse me there for a moment. I just went blank. So it has a constructor, which is the function which was used to create the array. Now, if I had just the regular object, yes, dun dun. If I had the regular object, the constructor function there is the object function, right? So that's how you can look up. The constructor basically tells you which function was used to create that object. So that's kind of a very important principle. So let me just switch back to the slides for a moment.
Sorry, Mitch, can I just interrupt there a second? You might want to take a look at the Q&A, mate.
Yes, I am. Let's see, I had them hidden from my site. Yes, thank you. It's a spelling. Thank you. That always happens in a presentation, right?
I'm sorry, that was just so funny. It just the Q&A just filled up, and it was just like, I've got to tell him.
Yeah, no, thank you. Because that's the thing, when you're presenting here, you don't always see it. That's the danger of doing live code. The benefit of doing live code is that you actually see, you know, what's going on, and that's what I want to dig in, because it's a conversation. I just don't want to give a whole lot of slides, because it's really, everyone will just, you know, kill over and die, because it can be pretty boring if you don't look into it. So let me just get back to the slides for a moment, because I want to talk about that function object. All right, so here we were. Can everyone, I assume, is seeing the slides again. So we've spoken about the prototype, how it looks up that chain, right? But when it comes to the function prototype, the function, this is a little bit of a different animal, all right? The function object is like any other object. It has the prototype, but it has this public prototype property. And the public prototype property is actually what is used as the hidden prototype property when the new operator is applied to the function. So that is why when you're creating an object in JavaScript and you say, you know, some function foo, and you say function.prototype equals this. Actually, let's just skip to some code quickly. So let's just go back there again. Right, so let's say, let's clear the console here. So I would have a function foo, right? Right, good. It does nothing. So this is like any other regular object. But now if I say, actually let's do this, let's use it as a constructor. And I say foo, and now I access the public prototype. And I say, you know, bar. Now, funny thing happens, right? When I say new foo, all right, let's say console. So what is interesting here is that f is a new instance of a function, and it's like that doesn't make sense because f is a regular object. So when you instantiate a function like this using the new operator, what happens internally is that foo takes the prototype property and effectively does something like this. I'm going to just try and put this in the clearest way possible. So you'd have some new object. All right. And what it would do is we'll say foo dot prototype. Prototype. There's my spelling catching me out again. So this would be equal to, you know, that's the same thing that's effectively happening. When you do a new foo, there's an object create, which is a standard method available on ECMAScript 5, right, where you can specify the prototype. So in this case, it kind of has the same effect. So now I can access that function directly in that way. So that's all that public prototype is, and that's why when you define objects in JavaScript, you use this prototype. You're just setting up the prototype object that will be used when that new object is created. So let's look at foo. So foo has, it's an instance, right, of foo, and you can see that his prototype has the function bar. And that function, of course, because it's an object, there's the prototype. You can navigate these prototype chains in any way. But internally, that prototype also has the object prototype. And that's why you define these things in this way. Inheritance in JavaScript is fundamentally just navigating up the prototype chain. Now, that's a great, it's simplification because that's what it boils down to. It's just that if you bring the mentality of .NET inheritance, where at runtime when you instantiate this object and it's one new big instance, that's not true. When you new up an object in JavaScript, it's multiple instances that collectively behave as one in terms of combining behavior. And when you start to get that, then suddenly all the various frameworks that implement some kind of an inherits function, which we'll do just now, will make a lot more sense. So I hope that's good. All right, so in this case, that's how it's set up. When I create a new foo, it's going to copy the prototype and insert it into the new object. So let's go to the slides again. Now, I'm trying not to be too winded by this, everyone. So if I am, I apologize. I just want to really get it clear in your head, because this is like one of those funny things. You'll read it here on the slide, and it kind of all makes sense. Oh, wrong slide. And then you go and do it in your project, and you're like, what was he saying again? It's sort of not quite making that much sense anymore, right? So, like I said here, I've got the new operator. Now, that writable constructor property, which points to the function object that owns the prototype. I'm going to explain that a bit more now, because I got myself tongue-tied just now. So I'm going to explain this a bit more. More about that. All right, so let's look at what we just did a moment ago. We had the function foo, all right. He has an internal prototype called the function prototype, all right. And that internal function prototype has an object prototype pointing to it, right? And of course that has null. But it has that public prototype with a constructor property and another internal prototype. And this is what is used to define a new object when the new operator is called on the function. So when you say new foo, it's not an instance of the foo function. It's effectively a instance, a kind of an instance of what, or the prototype is used to create an instance of a new object. And I hope that makes sense. And that is what you use as a basis for classes. So that sort of explains that. Now let me go on a little bit more. So what do we cover here? We've covered objects. We've covered primitives, right? Remember, Boolean, int, and string. That's all the primitives there are. Null and undefined are more state-like type things. And then prototypes. Okay. Now, let me just step back a moment in the slides. I want to go back. How do you get the prototype of an object? So let's take this example here. So I've got an instance of f, right? What you can do is you can say, so if I've got an instance of f, all right, I can actually get the prototype of f. And that's the actual prototype. Now look at the difference here. Let's examine this. There's the foo object instance, and there's its prototype. Now I'm just shortcutting. I'm going directly to that internal link. And this is the built-in function that you use to do that. There's another operator which is very interesting. And that is the instance of operator. So what the instance of operator does is it says, hey, I need to know which function, all right, was used to create a particular instance. And in this case, console, let's do this. I can say if f is instance of look at that. Let me just actually comment these out. Actually, no. When I'm asking f as an instance, I'm saying, are you an instance of foo? I'm asking the question not like in C# where, you know, where foo was a class. I'm not saying is foo an instance of that class. I'm saying no. I'm asking the question, was the foo constructor function used to create me? All right? Is foo somehow part of my prototype chain? Now here's something interesting. Remember I said that ultimately up the prototype chain, you can determine whether objects was used somewhere along the chain to create that hierarchy. And so both foo and object were used to create the actual final instance of foo. And that's really all the instance of operator is. So bear that in mind. A couple of things just to reinforce some concepts here. And what we're going to do now in a moment is we're going to build a little function that is called inherit. And we're just going to have animal. And we're going to create a dog animal and show various aspects of how we could do things like a superclass and a base class and add properties that way and sort of do in overriding in that sense. So that'll sort of bring it all together, I hope. I would encourage you as well, just by the way, go and look at a couple of books. Stoyan Stefanov has a book called JavaScript Patterns, where he goes on to different models for object construction. And it's very useful to read these things. Read it over and over and over again. Also, read, JavaScript, The Good Parts by Crockford and so forth. They're just good reference materials just to kind of drill these things in. You'll be surprised at how your .NET preconceptions filter into your JavaScript programming. And it gets you into trouble all the time. It still happens to me. You just got to do that mind switch. So remember I said earlier on about primitives. Well, type of is really what answers that question. So I just want to prove that I'm not talking a whole lot of nonsense. So, right, now let me show you something here. Let's just clear those out so we get through this. I'm just trying to keep things simple. Right, so remember I said earlier on the three primitives, right? There's a number, but let me show you something here. The type of tells you whether it's a function, whether it's an object. And here, that's weird because I thought I just said that function is an object. Yes, it is an object, but it's a more specialized form of object, right? It's got the public prototype and it can be invoked. I said that there's the three primitives, which is your numbers, your strings, and your booleans. So now let's look at that. Let's create a number, a string. All right, we can see that we've got a string and a number and a boolean. Let's just go false. Right. So those are your three core primitives. Now let me show you something really interesting. What if I said new number? Now it's an object. And the reason is that the primitive has a wrapper. Primitives are not objects. Primitives are primitives. But wrapper objects are wrappers. So when you're dealing with numbers or dates or strings, pay attention to what you're working with. Very often in JavaScript, when you call methods on like a string, let's say dot to uppercase. I know this is probably just going to fail text-wise, but if you call that, what's actually internally the interpreter is doing is it's converting that to its wrapper object, and then it's calling the method, which is actually in the prototype. So just bear that in mind, okay? Very, very important. But if I do a new string, text. There again, what have I done wrong again? Comments. Help me, people. String. That's it? Yes, thank you. Right. Notice it becomes an object and new. Right? False. Suddenly the three primitives are objects. Now the question is, okay, I thought that things, but let's try this. What about this? Now I'm just accessing the number as a core object. Now here it says the type of number is a function. And why is that? Well, let's look at what number actually is, for example. Well, it turns out number is actually a function, and in it's got some base public properties, and his prototype has a whole lot of information about a number. So it's got number-specific methods. And then you can follow that prototype chain, and all those things are all looked up. So even the number, the core number, has its base prototype object. And the same goes for strings. So let's say get object dot get It's just the core function object. So you can see it's all boils down to the same things. Now here's a funny thing. If you just call number as a function, because like I said, no, it's just a function, suddenly it becomes a number again. And that is because numbers, when you call it as a function, not as a new object, it returns the primitive value. The same with string. So that is why in JavaScript you call a function as these primitives as a function or as an object, but you just got to be mindful of which one you do. Now the question is why the heck are you talking about this in the context of inheritance? It's because all the built-in objects like array and all that all use these inheritance principles, which is just looking up the prototype chain. And if you're just mindful of which one is doing what, things that are really strange often begin to make a lot more sense. So that is why I think it's really relevant to sort of talk about it in these terms. But what I'm going to do now is let's go ahead and create that function or that animal hierarchy. And we're going to create an inheritance hierarchy to illustrate the point. So let's start with function animal. Right. And this is just a regular animal, so I can say prototype, prototype, dot, let's call it eat. So there's my eat function, and let's say right, makes sense? I can go ahead and say and a console.log. By the way, if you're sending me comments and stuff, it's just the resolution of my screen. I can't see all your comments. I have to switch modes to do that. Also, the text becomes too small. So in this case, the prototype has the eat function, and I can invoke it directly on the object, right? But what if I want to be a dog, all right? And so dog is an animal, all right? Oh, and I can say log. No. Right, that should. Right, that returns true. We see here that returns true. But what I'd like to do is I want to create a dog. So let's say function dog. And what I'd like to do is just to say, well, dog should really inherit from animal. So in order to do that, I'm going to write a little function called inherit. All right? And in there, I'm going to say, okay, let's take the child class and the parent class as arguments. And I'm going to do something very simple. I'm going to say, okay, the prototype here. Remember, C is a function, right? Prototype. I'm saying the prototype property, in other words, when we new up a new instance of the child, the object that needs to be used is equal to a new P. That's a new instance of P. Then, technically speaking, I should be able to have the eat method on the child object. So now I can say, okay, actually just call it direct. Dog, animal. Right. What did I do wrong there? Make sure that's good. Sorry about that. So, dog, so inherit dog. So what I'm doing now is I'm saying, okay, I'm modifying the dog object to be inherited from the animal object so that that's all good. But I would like to be able to say P dot eat. Wow, okay, suddenly I've inherited the eat method from the animal. Now, you're like, okay, this is strange because I'm calling a function to define inheritance. You know, in C#, in your code, you write your code and then you say, you know, foo or dog, and then colon inherits from animal. But remember, this is JavaScript. Like I said, you've got to breathe in. What you're doing is you're modifying the prototype chain so that its runtime behavior will new up the correct things. That's all what inheritance in JavaScript is about. So, you know, you can't, you have to, it may seem a little strange. Now, the nice thing about JavaScript is that you can express this concept in a number of ways. So you can write this function in a number of ways, like you could add an extends method to a function. Like a function, this is weird, right? I could do something like dog, dog. As you noticed, I'm not the most stellar typer, right? And I could say extends equals function. And the funny thing there is that will actually, that's kind of like adding a static method to the function object. Because remember, like I said, dog is just an object like any other, which means an object can have methods. So you can implement an inherit function in a number of maybe syntactically more friendly ways to what you're used to in like C# or other strongly typed languages. But I'm trying to focus on your conceptual level of what is happening in inheritance. So in this case, I've inherited E. Like, what I would like to do is let's do something really interesting here. I would like to say, I would like to mimic the behavior of what am I? So let's change this. What I'd really like to say is, when asked, what am I? If I've newed up an animal, I would like to say, I'm an animal. However, if I've newed up a dog, I would like to say, I'm a dog. And to accurately reflect that hierarchy, all right? So, the way that we really kind of need to do that is, let me just do this here. Remember I said earlier on about the constructor property. And And the constructor property of the prototype it's kind of like an informational thing. It tells you what function was used. All right. But because the prototype object is writable, when I set the property here, when I set the prototype, I lose that constructor property. So which means I have to add it again. So in this case, I say prototype. And that preserves a lot of the semantics. Is that right? Constructor. Yeah. So what that does is it preserves the default setup, because when you have an animal, all right, when you have an animal, it has that prototype property, not the internal one, the public one, and that public one has a property called constructor, right, which points back to animal. But now in the case of dog, because I've modified that chain, I have to reset that constructor property. All right, and if I do that, it helps me to get the right constructor function that is used. So if I say animal, what am I? Right. Let's hope it works, unless I've forgotten something. I am a dog. Well, not really. I mean, I'm a person, but you get the gist. Right, so that's interesting. So look at this. I defined the core methods, right, on the base type. And when I access it, I'm using this statement. But when I come down here, I correctly get the right instance. And that is because the prototype chain, again, is correctly set up to refer to the object which was used to instantiate it. So now, if we look at let's say constructor, and I look at D. And let's look at D and let's look at animal. Right. So when we look at animal here, we can see, okay, the prototype, in other words, the object which was used to create me, and the constructor is animal. But on dog, I correctly modified that constructor property to point to dog. If I didn't do that, all right, I'd still get a new instance of an object. But you kind of lose that sort of magic like in C# where it's one object. Here you have to do these few things because you've got several objects which collectively, it's like the Borg in Star Trek, right? We are self-aware. We work together as one. That's how you've got to think of all these objects in JavaScript. And that's the gist of inheritance. There's nothing much more to it. Now, however, supposing I would like to override some functionality. All right. So now what I can do is, this is pretty cool. I can say, what does it eat? I'm taking a shortcut. I bet some of you are saying, no, you're not supposed to do that inside. You're supposed to do it with the prototype. Yes, that's true. You're supposed to, I won't say supposed to, you can do what you want in JavaScript. You just got to do so with an attempted measure of intelligence. Well, I'm going to get myself into trouble now. Because if it doesn't work, I really look stupid, right? But I'm just kind of overriding the instance level of the object, and I'm going to say console dot log log. I might want to change the behavior here a little bit, so let's say what am I, and let's say as an my animal eat now look at that. What I've done is I've overridden the behavior here. Let me just do right. So I'm an animal, I'm eating as an animal. I'm a dog, I'm eating as a dog. But that overridden method, all right, this overridden method over here, I did it at an instance level. I could do it at the prototype, but then what I need to do in my inherit function here is I'd need to say, you know, for each, you know, sort of function in C.prototype. You know, then I would basically assign and add those on. And the reason I'm doing that is, remember, because I'm changing the prototype constructor property here, and I'm changing the prototype to be the parent. And that's why we need to do that. So I'm just taking a shortcut here in this case so that, you know, this eat is overridden. The eating method is overridden at the dog instance level. But with a simple little function and effectively 2 lines, you've got inheritance. And you can see why sometimes people can really overcomplicate this. But the reason most times it's overcomplicated is because people they're trying to force, it's like that original slide where they're trying to force this classical inheritance model where you've got, you know, total polymorphisms, you've got virtual methods, and and that is because at runtime C# is one instance, whereas at runtime JavaScript is many objects collectively behaving as one, and they're all up the prototype chain. And another thing that's different from C# is that the base class in an instance of C# is still the same object. This of the base is the same as this of the derived, whereas the base class instance in JavaScript is a different reference to a different object. And that reference is shared by all instances of that object. And that's very, 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 very important to remember. So the question is that, okay, but what if I have like some base, like what if I wanted to actually call the base method, right, on the prototype? Well, that's where it's actually quite straightforward. You just do this. You say C base equals P prototype. Right? Okay, what have I done now? Prototype. Prototype. That's right. It's not a function. Right. So what this does now is it allows me in here to say this dot base dot eat. If it works, are we good? Where's base? What have I done wrong here? Should be good. Uber P prototype. Da, 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 da. I'm not sure. I can't see it off the top of my head. I bet one of you guys can see it out there. You know what? I'll have to just have a look at that. I'm not seeing why I don't see it at first glance. But I'm going to skip that. I'm not going to get stuck on that. But that's basically what you do to inherit, to define your base types. And in that way, you can sort of access your sort of the base functionality up that prototype chain. And so that's the gist of it. I hope that that is interesting. Now, I'm just going to switch back to some C# code. And I'm sort of starting to wind down.
Apparently, Mitch, in
Yes.
the Q&A, John Bergman says you haven't called inherits at that point. That was why you had that problem.
Ah, thank you. Yes, yeah. You know, it's like, yep, that's right. So, that makes sense. Yes, yes. I'll get back. But I hope at least it drives home the point, guys, is inheritance doesn't have to be so difficult. It's really simplified prototype chain manipulation. And to the extent which you want to simulate classical inheritance, you can do that by doing these things. But I would just caution against it because, you know, if you have a very deep hierarchy chain, the cost of looking up that chain at runtime can be significant. So there's this notion out there of prototype inheritance where you just keep, instead of building a deep hierarchy chain, you borrow methods and behaviors from other objects and in that way define functionality. And it's much more in the spirit of JavaScript. But you can still do inheritance, and I use it a lot. I kind of mix a bit of both, of prototype inheritance and sort of normal classical inheritance through some kind of an extends method or inherits or so forth. But some of the principles which I've outlined here are sort of going into more detail in the book by Stoyan Stepanov. He does a much better job than I do of going into the details, and I'm running rather tight on time, so I'm going to just switch over a few things here, and let's go back here. So what I've got now is I've just got an instance of Sublime Text, because I want to point out something. This is like if I had a classical C# object just to connect the properties. In JavaScript, the way that you would think of this is that it's sort of a that's effectively what an object is in JavaScript. But what's really cool is it has this actually, you know what, let's call this sort of, if that was totally legit, that's the idea behind it. All right. And so if I've got in .NET, you guys all know that all instances will share the prototype, right? And that's the same in JavaScript. You've got to realize that it's an instance level sharing. And each object does not get its own copy unless in the constructor function, that is where you define your prototype methods. What am I saying here? Let me go back a moment. Switch to let's say I did this. Where's my object? Right, so yeah, I've got to find it. Let's say I did this. No pun intended. Is that every time that that dog was instantiated, the sum function, I beg your pardon, that sum function object or sum function would be overridden with a new instance, and so your prototype would be constantly changing. Plus, it would be inefficient. You could check and say if it's defined, then do it. The reason why sometimes you would want to do something like this, right, and it's just because if you want private properties, you can do things like bar, you know. So taking advantage of closures, you can implement private behavior, but this is nefarious territory because you've got to watch out. You've got to make sure that you don't redefine the prototype every time. So it gets a bit messy and you have to write too much code. But you can do it this way. And using closures, this allows you to also define private state and so forth. But for the most part, stick to the defaults. Stick to simple things like this. It's easy to read, it's easy to consume, and it's easy to use. Anyway, gentlemen, I think that is about. Let me just go back to the slides and make sure we've covered. Wrong content. There we are. So now some of these things make sense. This should make a lot more sense now, right? This structure, and if you're looking at this, you're like, oh, it's terrible. Yeah, it's not great, but once you understand the rationale, it's actually quite straightforward. It's really just a little bit more powerful version of this, which represents a prototype chain, and working up backwards, we can see we've gone all over prototypes. We've looked at objects as key value pairs. We've looked at objects. We've discussed primitives, and I hope to try and explain it. You've got to be careful that they're not objects unless they're wrapped. And, of course, all that slide. Watch out for that. I hope I've managed to explain some of that really weird stuff. And go and look more. You can talk about this stuff for hours because you can really take this and elaborate a bit. I think I've done about as much as can be consumed by a person. Just don't drown on me. Guys. Okay. Thanks, gentlemen.
Yeah, you've certainly learned me a thing or two, Mitch, and I consider myself a rather proficient JavaScript programmer. So, yeah, great presentation. There's things there that I've never even seen.
Well, that's great. It's funny because I was like, I'm so into C#. I'm C# programming and .NET is my primary vehicle. And yeah. I love inheritance. I've used it a lot, and you can do great inheritance. But when I got into JavaScript, I was like, oh, come on, man. Why does it have to be like this? It seems like...
Exactly. You sort of look at it and go, what?
Yes.
Yeah, I know exactly what you mean. But unfortunately, myself and the likes of you and many developers these days, we're getting dragged, kicking and screaming more and more into the front end these days. So it's something you have to learn, and you do a really good job of getting these concepts across, it has to be said. We've been asked a few times if you will be making the slides available.
Yes, I believe, if I understand, so I uploaded them, right, as part of the presentation. So is it not available as a download, as a link?
I have it already.
Great.
Okay, so you're going to put it up there so people can download it from handouts then, Brian?
Yes.
Okay.
Now, obviously, I can't, the code samples, it was kind of on the fly stuff, right? So it's those, I don't like to have formal projects, code samples, but I think that I try to limit it just to one page, so hopefully the video will be sufficient there.
Yeah, well, we're recording the video as we
Yes.
usually do, so
Great.
that's going up on our LIDNUG page.
Excellent.
You know. Where will the video and the PowerPoint be? John, the video will be up on YouTube/LIDNUG. Give us a few hours to record it and mix it down, and we'll get it up there as soon as possible. The PowerPoint, if you look in the meeting that we're all attending at the moment, up in the top right corner next to where it says feedback, you will see a white icon that looks like 3 pages and a little yellow icon next to it. The white 3-page icon is the handouts download, and I believe Brian, as we speak, is just uploading Mitch's PowerPoint to that icon for you all to download.
Yeah, it's uploading it as I speak. Yeah.
There we go. So, anyway, thank you very much to Mitch, everybody. Yet another enlightening presentation. When are you coming back for us, Mitch, and what are you going to do next time?
Hey, I want to do lots. I don't have anything on there, but I will try not make it a year again before I'm back. I think I have a lot to share with JavaScript because I've really been digging down the last year. So I will try and get back ASAP. I mean, because there's so much good stuff in JavaScript, and it really can be simplified. The problem, like I said, is we have so many libraries, and we need it, right? Because we just got to get stuff done.
Oh, absolutely, absolutely.
But it helps to just understand the core, like those primitives. You know, I didn't realize that those primitives were there, in the sense, because you kind of work under the assumption that everything's an object, because that's what you generally hear. But the implications are quite dramatic, because sometimes you build these objects, and then you use these primitives, and then they start behaving like objects, when they should be primitives, and primitives when they're objects, and you try and inherit, and errors occur, blah, blah, blah.
And it blows your mind, doesn't it? It really does, you know. And then, of course, throw something like TypeScript or CoffeeScript and that into the mix. And people just sit there and look at you and go, come on, dude, what?
Yes. No, it's true. Can I tell you one thing? I don't want to be a shameless plug because it's not appropriate, but I will say that on the Wintellect Now, I did some videos on TypeScript, and I covered some of these concepts as well in JavaScript for C# programmers. And given that there's a free demo, let the guys go and have a look there as well. I'm really not trying to just push it here, but there is some good material there. I still want to do some shorts as well, where I do like 5-minute shorts and make that available as well, where you kind of delve into these core nugget concepts, you know.
Well, strange you should mention that. I'll make a mention of this now while we've still got some of our members listening, while we're still recording.
Yeah.
But something that we at LIDNUG have been wanting to play with for a long time now, and this is for all of you members out there, if anybody has a small subject that they would like to put on the air for 10 minutes, we'd like to hear from you, because we're looking at people who would like to do 10-minute nuggets. You know, just before a major presentation such as the one that Mitch has just done, you know, come forward, contact me, contact Brian, contact other members of the staff. You know, let's make a list of people who want to do this, because we want to get you guys online. There's so much hidden talent out there, and so many things that people should be sharing, and we've got a platform to do it.
That's great.
You know?
No, that's great to know. I'm definitely interested in that.
So we'd like to do that, especially because it's kind of like virtual Grok talks, isn't it?
Yes, exactly. Yes.
You know, and I think there's a lot of merit in those Grok talks.
That's right.
Yeah. Right. Well, I'm going to say thank you officially now and goodbye officially, so I can turn the recording off. But feel free to stick around a bit if you want, Mitch.
Awesome. I tell you what, I've actually got to run. if you don't mind, I would love to chat, but I've actually got to run, so, but let's just be in touch. Actually, I've got about another 5 minutes, so yeah, it's cool.
So, thanks again everybody for attending, and we hope to see you at our next presentation.
Yeah.
Cheers.
And the handout is